I'm very happy that we have André here with us today. It's a great honor to have you here, André, and I'm very much looking forward to your presentation. I've seen several of your presentations, and I've always learned very interesting new stuff. And I'm sure that will be the case today as well.
No pressure.
And so I don't want to delay you any further, and let you do the talking from now on. Thanks for joining us today, and I hope that if we are able to have in-person meetings again, you and Kamman will visit us in Berlin.
That would be cool. I've been in Berlin once, and I vaguely remember it. I loved it. That was
You have to repeat.
Will do.
Okay. So André,
All
stage
right.
is yours.
Let me share a screen. Let's see. Which one? This one? Is it this one? Yes, it's this one. Yep. All right. This is always getting used to a bit. I have a 49-inch ultra wide, and I feed it with two cables from the computer, so it's actually two screens for the programs that don't like the ultra wide stuff, like PowerPoint presentation mode. It doesn't understand these little subdivisions and such. All right. Where shall I start? Not too much about me. I'm a geek. I'm a SQL Server guy originally. I've been in IT since 1989, hence the gray hair. I'm a data engineer. I've been a SQL Server DBA for a long time, but I live mostly in the data warehousing world, fact and dimension tables and whatnot. I've done a lot of stuff with Synapse, but not when it was called Synapse. More what it was before, when it was still in racks in people's data warehouses, in people's data centers, when it was called PDW and APS later. I've done a lot of things with them already in that time. What else? I'm a Dutchie. So that's why I'm doing this in English. My German is not that good that I could do a session in German. If you have a question and you can't find the word, try it in German. I can understand German very well. That's no problem at all. Ich habe Deutsch gelernt von der Sendung mit der Maus. When I was very young, I looked at we had two Dutch TV channels and like 5 German channels or something. So when I was 4 or 5 years old, I already watched TV in German. So I learned it from the A-Team. Ich liebe es, wenn ein Plan funktioniert. That kind of stuff. So since I never speak it, it's hard for me to find the words because I don't practice. But understanding that never goes away. So if you have any questions and you can't find the words, just try it in German. I'll understand it. Having said that, let's get to Azure Data Warehouse. Now, first of all, most important thing. Maybe not the most. Okay. Let's see. I am using Azure Data Warehouse at the moment for a bank in the Netherlands, and it's a fraud and compliance department. So I can't show anything from that thing, can't show you any data, and I have to be a little bit careful of what I say about it. I can't even specify certain use cases. I'd have to talk around it a bit. So if you see me think about explaining what kind of queries we're running, that's because I'm not allowed to say a whole bunch of things. What I can say, it used to be 150 terabyte on-prem SQL Server. It's a complete side note, but if anyone ever comes up to you and says, "Oh, SQL Server doesn't scale that well above insert gigabytes here," this was an 8-core VM and a whole lot of storage underneath. It scales fine. The only thing it doesn't do well, and this is also the reason why we switched to Azure Synapse, is if you wanted an index, it takes 4 days because it was just a few tables. And one of the tables, for instance, has 80 billion rows in them. So select count star would take a while. and an index would block the whole thing for days. So we'd have to plan it in a long weekend, an Easter weekend or something. That was interesting. So now we have Azure Data Warehouse, and that went better. I'm not going to say it was perfect when you just switch it on and start using it and go, yay, everything is perfect. There are things that you have to think about. And this is, I'm going to try and explain what we had to think about, what worked well, what didn't. I'm going to say 80% worked really well out of the box, and 20% we had to think about it a bit. And there are a few things that we figured out that just didn't go the way we expected, and we had to find a workaround. And we'll get to it. Now, first, also, if you have questions, I cannot see the window when you raise your hand or something. As soon as I start presentation mode, it takes over everything. So if you have something, open up your mic, just break in. It's fine.
André, I'll monitor the chat, and if there are questions in the chat, I'll just interrupt you.
Cool. Yeah, no problem. Just break in. It's totally fine. Some simple things first. Azure Data Warehouse is a service. It lives in Azure, and you don't have a lot of control over it. You just switch it on, and you tell Microsoft how much money you want to spend, and you get a certain amount of CPU, RAM, and I/O power based on the DWU, the data warehouse units that you choose. Now, this is an older picture already. This goes from 100 to 6,000. I think it goes to 12,000 already. But this has a reason why it goes to 6,000, and we'll get to that as well. But basically, you move the slider, it gets more expensive, and while it does that, it also gives you more power, and it scales nicely. We'll get to that as well. Now, what does it mean, this scaling? How does that work? Because I spoke to a lot of people that think that it's just a SQL server. That's absolutely not the case. So it consists of a bunch of compute nodes and a control node. And you, with your application, whatever you do, or Management Studio even, you can just connect to it and it behaves like a SQL server. You're connecting to this control node, and it makes you think that it's a SQL server, but it's not. It's really not a SQL server. It just sits in front of all these SQL servers. And it has a little SQL server itself. It has a bit of a meta database, and it can store some intermediary results, but it's not a SQL server. If you send it a query, it will take your query, chop it up in pieces, and decide which SQL server to give it to. And that depends on where the data is. And the answer is it's probably everywhere. Now, where your data is going is an interesting thing, because you do not have one table either. If you do create table inside this thing, if you connect to it, to this thing that's not a SQL server, and you do create table, you're getting 60 tables, 60 tables all the time. You can't configure that you cannot set it in one way or another. You get 60 all the times. And then when you insert data in that thing, your data goes everywhere. If you insert 60 rows in that, what you think is one table, you actually get one row in each of the tables. Depends a little bit on the options that you use, but we'll get to that as well. So what happens is you're talking with your application to the control node. You send it a query, it breaks it up, it sends it to all the compute nodes, and those are SQL servers. And they are attached to storage, so they have storage attached to them. So they ask the question to their tables and bring you back the result. And that goes back up to the control node and gives you the result. This is all the time. So this gives you also overhead, basically. So first things first, because of this overhead, and a few other reasons, we can get to that as well, is for data warehousing. If you have an OLTP system where you need 10,000 users and they do a singleton updates and inserts and select statements, and you need your queries to be answered in 10 milliseconds, 20 milliseconds, that is not what this is for. That will not work. because of this overhead, for one thing. Now, how many of these compute nodes do we have? And I'll show you demos later with queries, and you can see the overhead yourself and also make some choices out of it. Now you have this compute nodes, and how many do you have? We already figured out that the storage, there's 60 tables all the time, not configurable, but the compute nodes are. You can scale these things. You can say, and this depends on the DWU that you set. So you can say, I want 5 of these things, or I want 10 of them. This depends. You can just move the slider and you'll get more power, and that means that you get more of these compute nodes underneath the one control node. There's only ever one control node, and there are always 60 tables underneath, 60 storage items. Let's call them that. Maybe they are Azure SQL databases like in this picture. Maybe they're not. This is not documented anywhere, I think. I don't know either. So they attach to your storage. So you can have 3 as well. Now, and we'll get to how that attaching works later as well. There's another thing that you can do that makes it interesting. You can pause and resume your workload. So you can say, you know what? I want nothing. I just want to pause. I do not want to use it right now. I have a whole bunch of data in there, but I don't use it right now. I don't want to query it. I don't want to connect to it. So just pause the thing. So you hit pause. You can do that from the portal or with a command or with PowerShell, whatever your favorite method is. But this pauses it because it shuts down the control node and the compute nodes. And this control node is how you connect. So you can't even connect anymore. Some would say that makes it free. That drops the cost to nothing, which is not true. You also pay for the storage that you use. So the compute node cost is gone, but you still pay for the storage. Keep that in mind. It will save you about half. Not completely true. They keep tinkering with the pricing, but that's about it. One thing to keep in mind, you can only pause and resume with the same number of compute nodes. So you can't say, I want to resume this with a lot of compute and then pause it and then resume it with a little bit of compute. You can't do that. When you resume it, it goes to the original compute and then you can scale it down. Just a side thingy. Now, how does it work? Your tables are basically spread around, let's call them buckets, hence on every slide deck, I have different colors. Sometimes some conference sends me a slide deck and they suddenly appear in different colors. So them being orange, I didn't see that coming. Nothing to do with the fact that I'm from Holland. Didn't want to say anything. Anyway, you have when you start this thing out, the lowest setting that you can do, and it doesn't, when you create a new one, it doesn't start as a DW100, but as 1000. Keep that in mind. So you need to move the slider back down to a 100 to get the cheapest option. This is good for development purposes. When you move it to a 100, all your storage is connected to the one compute node. Even worse, you get a compute node per 500. Per DW 500, you get one compute node. So when you create a brand new one, starts with a DW 1000, that means you have 2 compute nodes. So basically 2 SQL servers attached to your control node. And they're quite beefy SQL servers. So that's pretty powerful already at DW 1000. But if you move it below the 500, you are starting to share your compute with others. So the DW100 is a shared SQL server, and it has all your storage. So it's not faster at all, but really good for development purposes, and it saves you a lot in price. Now, if you move that slider, for instance, to a 200, now it splits up the data. You have 2 SQL. You're still sharing up to a 500, but it splits it up. So now your data is 30 buckets are on one side and 30 buckets are on the other side. And if you go to a 300, etc., it splits it up even more. Well, etc. And 500, you will have one compute node. And you can go up to, the original one was 6,000. That obviously has to do with, they did something with, when it was 6,000, you would have a compute node for every DW 100. So 6,000 meant you had 60 compute nodes. So you couldn't get any more because you can't have two compute nodes connected to the same storage. There was no way to divide it further. And I think Microsoft just went with, let's just build bigger machines. Let's not scale that out, but scale it up. That has to do with the fact that with how it distributes your data. If it's always 60 and suddenly you make it 120, all your data has to be reshuffled to fit in different buckets. It has to be moved. You can't just have 60 full and then 60 empty ones. That doesn't work. This is something that you had to do when it was still on-prem, when you had a rack with servers and you bought an expansion for the rack. It would take a while because it had to reshuffle everything because you would have more buckets. That's not the case in the Azure version. Now, let's go to a simple example. What does this mean? Well, that means that, for instance, if you do something simple like a count star from a table, you can't do that because it's not one table. There's 60 of them. So what does it do? Well, it sends the count star, count big in this case, because we're counting on so many rows that it goes beyond what an int can have, so more than 2 billion. And it sends it to the control node, and the control node goes, all right, well, I have 4 compute nodes, so I'm going to send to each of my compute nodes, I'm going to send 15 select count star from these tables. And you can see them here as the normal table names, but underneath the covers, I guess they're all GUIDs. They don't have the real name. Maybe the real name is still there. I don't know. There's some metadata about it. You can see it. But basically, every compute node gets the command, okay, your compute node, you have 15 tables and I need a count star from all of them, please. And it will do that for you. It will create a temp table, grab the data, store it in the temp table, then sum it and give it back. So that's what happens here as well. The control node gets all the 60 individual results, moves it up, and then sums them because it has stored them in a temp table, sums them, and then gives them to the user. And then everybody has to clean up their temp tables. Can you see how this wouldn't work for an OLTP system with all this overhead of creating temp tables and storing intermediate results and bring them back and splitting everything out? This is the general rule with everything that is parallelized. If you have to go parallel, there's overhead in creating something that goes parallel, and there's overhead in pulling it back together. That's how this works. Now, how does that distribution work? Can you at least figure out where everything goes? Yes, you have some options. First one, pretty simple. You have data, and if you load it, you do this on the create table statement. You can say create table with distribution is round robin. You can just specify what kind of distribution your table would have. Now, if you start loading data in that table, if you do bulk insert or whatever, bulk insert might not be a good thing, but we'll get to that. If you start loading data in there, it will go, well, you're going to go to bucket number 29, you're going to go to 30, you're going to go to 31, und so weiter, yeah, etc., etc. It will just go like a like a dealer in a card game. You get one, 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 until we're done. Perfect for distributing the load amongst these systems, right? They always, whatever you do, they will have the same amount of work to be done if you query this thing, because they all have to go through all the data in all the buckets, and everybody has the same amount of data from this table. Nice, right? There's another option that you have. You can take, for instance, the key of a table, but it could be any column, and you can say, you know what? Hash that thing. There is a hash function, and the hash function just basically says which bucket it goes to. So the hash function basically generates a number between 0 in 59, I'm guessing, or 1 in 60, I don't know, but 60 different possibilities. And it will calculate the hash and put it in the corresponding bucket. So if the key of the record is 1 and you'll hash it, it might go to bucket 5. And then you have a key 2 and it might go to bucket 31. And key number 3 might go to bucket 46. And then you get key number 1 again, and it will go to bucket number 5 again. This is because it's the same key, it hashes to the same place. This is useful because now you get everything that hashes to this, that is the same value in the same bucket. So where could this go wrong? What would be not a good hash key? For instance, sales date. Anything that you would put in a group by, basically, or in a where clause, would be a bad plan to put as a hash. Sounds a bit counterintuitive, but why is that? Imagine every night you load all the sales from the whole planet, from all your supermarkets or whatever you have, into this thing, and you get 100 million new rows. And because you hash it on sales date, they would all go into the same place for the whole day. And then the next day, everybody runs their reports on the system. And what are they interested in? The data from yesterday. What is new? How did we do? And that data is all in one place. So there would be the one poor compute node that has to do all the work. And the other 3 didn't get any new data, maybe tomorrow. And they can't help. So it's a bit skewed, as they call it. And it's not equal. So it might make it slower because you don't use all the compute power that you might have. There's one other problem. Null values. They always go in the first bucket. So if half your data is null and the other half has a value, that first bucket gets most of the work. And you either have where this key is null and it always has to go there, or where it is not null and then that one never has to do the same amount of work. Same problem in a different way. There's one more, and I don't have a nice animation for that. I keep expanding this deck. But there's one more, and it's called replicated. Replicated is useful if you hash. So why? Let's get to that. Why? Why would you use it this way? Well, round robin, easy, right? You get 1, you get 1, you get 1, you get 1, you get 1. So if you do a select blah, group by, bloody blah, here's my very large query that gets me a lot of data and I want a summary per year or something, but I'm only going to use one table. I'm not joining on anything. I'm just using the one table. Go. And it will go, okay, it's round robin. I'll just give everybody the same query and I'll get the result together and give it to the user. Good. But now comes a problem. I want to join on something. Very classic approach. Fact table, huge fact table, and I've round robined it. But now I want to join on a dimension. And what if I did the dimension round robin as well? What would happen is that, so here's a rule. It does not go across these buckets. It cannot do that. So your bucket needs to have the data to join on. And that would be sheer luck, right? If it would have that, it wouldn't be correct. Bucket number 1 might have some dimension records that it can join on, but some might be in bucket number 15 and it needs it in bucket number 1 because that ID shows up. So the join would be incorrect. The data would be incomplete. Microsoft wouldn't make a lot of money with a product that does that, right? So what happens then is it moves the data while you're running your query. So you run a query and Azure DB just goes, I don't have stuff in the right place. Hold on. I'm going to reshuffle this data so everything is in the right spot. Then I'm going to join and then I'm going to give the result back because there's no way I'm giving an incorrect result. That would be lame. So you can choose this yourself. You can do this yourself. If you have 2 large tables, and you're joining these things on a certain key, you can hash them on the same key. So all the data that you're normally joining on would go in the same bucket. And then when you're joining it, it knows that. It goes, oh, they're hashed on that key that you're joining on. So the result would be correct because they would be in the same bucket. I can just join. Nice. And another trick with a large fact table and a small dimension table, or multiple small dimension tables, is the third option that we just discussed, replicated. Replicated just means a complete copy of everything on every node. So no matter what you do, it's always correct because you can join always on this dimension because the dimension is a complete copy and it's everywhere. So then you can do round robin with a replicated dimension, round robin fact with a replicated dimension. All good, no data movement needed. Is that bad that you have data movement? Yes, because it will be slower. Do you have to prevent it at all costs? And is your situation wrong and will never work? No, no, no. There are many situations where data movement cannot be stopped. Just let it do its thing. It will move the data for you. This is the cool part of Azure Data Warehouse. It will come up with an answer. It doesn't matter what you throw at it. If the data is not correctly formatted in the right way, it will move it around and get you an answer. That's totally cool. You just want to make sure that your 80-20 rule, if you already know, I have a huge fact table, bunch of dimensions, I will help this thing a bit because I know what's going to happen. So you want to prevent it as much as possible, but it's not a bad thing if it happens sometimes. Now, this is why it should be evenly distributed, right? If you have buckets that are not full evenly and you start, I guess, drinking, this is water, but okay. You start drinking, some will be faster, some will be slower, and you're only done when the slowest one is done. So when it's completely even, better. Simple, right? So these are the two goals that you have when you design data warehouse with Synapse. Synapse Analytics dedicated SQL pools. Seriously, who comes up with that? It used to be PDW, and then it became APS, and then it became Azure Data Warehouse, and now it's Synapse Analytics dedicated SQL pools. Okay, fine.
Good job, André.
Yeah.
The way we spell it.
I still say PDW sometimes, which is the very first thing that you had in it on-prem. Oh well. These are the two things that you have to get right, balance basically. And there are other things that you have to mind. Well, we'll get to that as well. Minimize the skew, so make sure everything is somewhat equal. So round robin is really good because it's perfectly level, but that might cause problems on joining. And you want to minimize data movement because if you start to hash stuff or join on two round robin tables, then it has to move data. And so you want to minimize that as well. And it has to be a bit of a balance there. And which one you focus on most depends on your situation. This bank thing, the tables were over 100 gigabytes each, but we never really joined them. There were a few others that we had to join, and we chose a completely different method of storing them. So it depended on the situation. We were totally in love with the round robin scenario. It would have 100 billion rows, and we would go, give me everything with this ID. I have to be a bit vague about what kind of ID it is, and show me the data. And it would just go, all right, it's a ton of data. I'll just go and go through everything. No problem. So there's a whole bunch of data movements. You'll see them. They change all the time. This is probably old already. You'll see them in the plans and in the documentation. Don't worry too much about them. Once you start tuning it a bit, you'll figure it out. But there's shuffle moves, partition moves, broadcast moves. Just means replicate. I'm going to give everything its own copy. That's a broadcast move, etc., etc. Don't worry too much on this now. One place where you do have to watch out a bit is, right, keeping an eye on the time here. One place where you do this is doesn't have that much to do with querying, but with loading. And with loading, this might also be important. If you can use the old school loading, right? The SSIS, bulk copy, the BCP, old school command line thing, an insert command, that works, no problem. That's just it, fully supported, no issues. It just works fine. Only problem, it goes to the control node. Then the control node decides where it goes. So if you have a hash table, the control node has to do the hashing as well. So it just blows up its CPU and it will just have to decide where everything needs to go. Now, what they also do is there's a system in Data Warehouse, and that's in normal SQL Server these days as well. And it became the de facto nice big way of importing data. It's called Polybase. And if you use Polybase, it doesn't go through the control node. It gives the compute nodes the command to grab the data. And this scales because the more compute nodes you have, the faster you can load this data. Now, how do the compute nodes know which data to grab? They don't. They just grab a portion of the data, hash it, and send it to the one that should have gotten it. That might happen. There's a lot of data going back and forth between the compute nodes. And even that is faster than just using BCP or SSIS or anything that uses the bulk insert API, the bulk API. So use Polybase if you can. We actually had, this is not a data factory talk, but we had quite the complex data factory where we made sure we had a whole bunch of files and gave them all in one go to the as a Polybase command to the data warehouse, where it would try to ingest all these files. There might be a file with a problem, so it would break, and it would do that every now and then. So most of it was fine, and sometimes it would break and go, this file is not the way I expected it to be, like commas missing or something. And then we would scale back to one file at a time, which was slower, and then it would only break on the file that was broken, and then we would switch on the error handling, which was even slower. And then it would just insert all the rows that it could and tell us exactly what was wrong with the one or few rows that it couldn't ingest, and then we could fix those and move on. So it was like a heavy scenario. On-prem, we used bulk insert, and it would block a lot. And as soon as we had problems, we would be behind for an hour or more hours, sometimes even for days. And then when you needed to catch up, everybody needs to leave the system alone a bit, and then it would eventually catch up. That's not cool if you're investigating fraud cases. You want to have all the data as much as possible. And with this scenario, once we switched to Azure Data Warehouse, it could just keep up. There's no problem at all. And we figured out that we could even switch it to the per line thing per file, but it wasn't that fast. And once we started doing the bulk insert with a bunch of files and then scale it down when we hit an error, oh, so good, so good. That was so nice. It was just, are we behind? No, we're not. It's fine. So that was a little sidestep, but just keep that in mind. If you can, use Polybase. If you have an old school application and it has like SSIS built in or something, it will work. It will work. It's not even that slow, but Polybase is so much faster.
André,
So,
might I ask a question here? Because I think you are aware of the new way to load data via the copy command. Did you try this? Did you test it?
I tested it while it was still not released yet. Mm-hmm. And it seems like a different way of using Polybase and get rid of some of the disadvantages that Polybase has, but we haven't used it in production yet. Okay. For instance, Polybase has a limit of a megabyte per line or something. There's a few things that it doesn't do well. And there's the copy command. Seems to be like Polybase 2.0 kind of thing, but I haven't tested it too well. So one other thing that you have to keep in mind, if you, for instance, use SSIS, if you think, oh, we have a ton of SSIS and we're not going to change that. So we're just going to use SSIS. It's not that much data. It will be fine. It might not be. SSIS typically does, for instance, if you have slowly changing dimensions type 2, where the classic thing where you take a record and you put an end date in it and you make a new record and that's now your current record, that kind of thing. Because this thing by default, and it runs the best with the default setting, uses column store, that might slow you down as well, because column store has some interesting stuff as well. Now, shall I go, because I have column store now, or should I do some demos? Where are we? I'm already talking for half an hour, right? Let's show some stuff. Where are we?
Yeah, show some stuff.
I have some column store stuff in my slides next to explain some stuff. It's important to know, but let's do this first. I'll show you some stuff. I have right here a Azure Data Warehouse. You can see the icon is a bit different. It's like 4 SQL databases. And this is a DW 2000. So this is if I would leave it running, this would be a 10,000 euros a month kind of thing. This is a beast. But I just switched it on right before the session, and I'm going to switch it off right after this session. Trust me. Famous last words. I'm so going to run out of my MVP credits if I forget this for a night or two. And you can see, I don't know if you can see that, it might be a bit small, but the icons of the tables are different. Some of them are like, they seem split, like there's a space in the middle of most of them, and down to the bottom you can see post history from the Stack Overflow database, where there's like a yellow line through it. So I've taken a different approach with loading them, and they all have their little icons. Now, let me show you what it does. I have here select from fact internet, sales, and join dim customer. And both of them are round robin, which, like I told you before, that's not a good thing, right? Now, if I run them, it's gonna, I'll just run them. This would take what, 20 seconds or something, not because this thing is so slow. It's because the data now goes from the Azure Data Center, which is in the same province that I am now. I'm in Amsterdam, but it has to go across the internet through the Wi-Fi to me, and there's 60,000 rows. Now, Management Studio will allow you to get a query plan for this thing, but this is the weird query plan that is different than you would normally see. This is not a SQL Server query plan, because it's not a SQL Server. You're not talking to a SQL Server, and it will already tell you, you know what? I am grabbing some data from 2 tables, and I'm shuffling one of them. I am moving data so I can join it. That's because they're both round robin, and I'm joining on customer key. So probably it takes the smallest table, reshuffles it and rehashes it on customer key, and then tries to do it again. And if they're both round robin, it needs to do that with both of them, I'm guessing, or else it won't work. Now, let's see. Because that query plan is not very useful. And you can also do an explain. It's almost like an Oracle system here. But you can do an explain. It comes back with an XML. Oh yeah. Standard Management Studio will not get you enough, so you'll have to go into Tools, Options, Query Results, SQL Server, Results to Grid, and then you may want to, that XML data, you may want to make that bigger if your query plans are large, or you won't, or it will cut it off. Just a small detail. Now, this is not a query plan that Management Studio understands. So you're just going to have to look in the normal XML. Now, problem, if I just paste it here, everything will be on the same row. So there is a trick. If you create an XML file empty, just completely empty, and just open it in Management Studio and paste it in there, it will format it for you. Just paste it in an XML file, and it will do it for you. And you can see here already it does a shuffle move on customer key. So it moves data around, and it creates tables for the temp result, and then it drops the tables again. So there's a whole bunch of overhead to answer this query. And you can see here that it has 4 nodes because this is a DW 2000, which has 60 distributions. They all have. You can't configure this. So everybody has 15 distributions. So far, so good. And it has to do a whole bunch of stuff to answer this query. Now, you would normally, if you have a big, where were we? Here. If you have a bigger table, you would round robin the fact internet sales, maybe, and then replicate the mentioned the dim table. So have a copy everywhere and round robin the fact internet sales because that's nice and even. And then since you're joining on something that's available everywhere and completely, that should go better, right? So let's look at that query plan. And I can just grab it here and see how big this one is. I'm going to replace it with the new one. Aha, already better, right? And now you can see that it doesn't have to move anything, because it can just go, okay, I have 60 distributions. They all have a part of the fact internet sales. Everybody has a copy of the dim customer. So just run those queries, give me back the result, and I'll put them together and give it to the user. That's all. No temp tables needed, nothing. There might be a temp table on the control node. So much better. This is what you get if you think about where things go. Now, how did we figure out what the best way was? Well, we tried. This is the cool part of, where are we? Keep losing it. There we go. This is the cool part of figuring this out. We had a 60 billion row table and an 80 billion row table, and they are terabytes in size. There was one table that was well over 20 terabytes in just one table. And on-prem, there was nothing we could do with it. When we would want to experiment with an index, we would have to go to the SAN team and go, do you have like maybe 40 terabytes of extra space? And they would just laugh at us. And in Azure Data Warehouse, guess what the limit is? There is no limit. Well, almost no limit. If you do not use column store, there is a limit, and I think it's 60 terabytes.
That's correct.
So if you use column store, no limit. Go ahead. As long as you have the compute power, you can wait for it, and then everybody else can run the query, so you can just move the slider a bit. We did this actually. We had this 20-something terabyte table, and we experimented by making copies in production. We just went, I'm just going to see if this hash key works better. Copy, boom. And it was brilliant. We loved it. Let's see if I can. Ooh, they always warn me to not type in a demo, but it's create table as select. It's called. So it's create table fact. No, let's do a bigger table. I have the post history. Post history copy with no need to shout. Distribution is round underscore robin, I'm guessing, as select star from post. Copy. Now, to give you an idea, do I have a count? Yeah, here's a count. Oh, I just did that. 133 million rows. On-prem, this would take some planning. This would be off in the hours outside the normal working day. Here, if I didn't make any typing mistakes, looks like I didn't, I can just run this in production and go, as long as you have enough power. The thing that Synapse is really good at is dividing the workload. There's a lot of options to tweak and give your user more memory than not memory, more compute power, because it's CPU memory and I/O. This is all together. But you can go into a larger resource class if you need it. There's a resource classes, and you can't give everybody the larger resource class because there's only so many performance buckets that you have to keep changing the name of the thing, and they keep changing how it works. But you can only go with so many people having active queries at the same time, and so there is a limit to it, and it divides it nicely. Things that you have to watch out with is Power BI with a lot of parts on your Power BI report, because it runs all these parts as a separate query to your data warehouse. And if you give that too many resource classes, you might run into the limit. And then when you hit the limit, it will just wait. So you need to think about this if you have a lot of users. To give you an idea, this system at the bank had over 1,000 users, and it ran fine. And that limit is nowhere near 1,000. It's like 100 or something, 128, I think, or something. And if you tweak your queries so it's fast enough and they disappear again, it's concurrent queries that you might have a problem with. So it does exist. It might be a problem, but don't be scared. Don't be scared. It might be fine. Depends on what kind of queries you're running. So if you design the way you store your data wrong, and every query has data movement, and all your queries take 5 minutes to run, you're gonna run into it. You might have to take care of it. Take care of that. As you can see, it took 38 seconds to make a copy of a table with 133 million rows. It doesn't care. This is how we figured out what to do. Just make copies, mind you, clean them up afterwards because you do pay for the storage. But it works nicely. Now, I showed you the, no, not that one. I'm going to get to that one later. There are a few ways to look at query plans, but it is a bit limited. Can I get to the actual SQL Server query plan on the underlying nodes? Sorta, kinda, yes, but not really. The query has to still be running, which limits you already a lot. You can absolutely get the query plan, that distributed query plan with if it had movement or something. It keeps a copy of that. There are nice DMVs for that. But what it did underneath the covers with the actual SQL Server, the query plans that we are all used to on SQL Server, those things, it's sort of kind of possible, but not really. It's kind of hard. It's a bit of a black magic. It's this one, DBCC PDW show execution plan, but it's kind of, you have to be a little bit lucky with your query. So you can do some tuning. Also, really cool feature that Synapse has. You can label your queries. So if you have a classic data warehousing schedule at night where you go, okay, we do the staging, and then we do this, and then we do the fact tables, and then we do the dimension tables. You have all these layers and steps. You can name these things, and they'll show up as a label inside your query results, and you can see how fast it was and where you're going. So that's kind of cool. That works really nicely. Now, other problems we ran into, and for that I have to switch back to the deck. Am I doing on time? 45 minutes? Okay, good. Let's go to the deck again, because there's another thing that you have to keep in mind, and it's quite important. Do you pick row store, which is the normal non-clustered and clustered indexes that we already know, or do you pick column store? The answer is, sorry, it depends. We had these thoughts about the limit of the size. So we thought, okay, you can have 60 terabytes if you don't use column store. We had one table already that was close to 30 terabytes. So we were thinking, okay, if we start adding a few columns to that, or keep a few more years of data, then we might hit that limit. But I doubt that many people have this. Yeah, who has a 30 terabyte table with hundreds of billions of rows, right? Who has that? So that might be a problem. If you have a lot of rows in one table, a lot of data, then you might have to take care. But there's a few other things that you have to be aware of when you're using column store. We had one scenario where column store did not work for us, and I'll get to that now. Now, the default is column store. If you don't specify anything, you're getting a column store index, a clustered column store index. But you can No problem at all. Use non-clustered indexes and clustered indexes, like in old school on-prem SQL Server. No problem at all. That will work. Now, how does column store work? One thing first, you already see in this slide that I'm saying you have to have a large data set with more than 60 million rows. Why more than 60 million? Because column store is divided up in blocks, and these blocks, it's compressed data basically in blocks. And the perfect block size is 1024 times 1024, which is slightly over 1 million. And you have 60 tables. So in order to fill these blocks perfectly in a perfect world, it's better if you have more than 60 million rows. Will you ever hit the perfect world scenario? Maybe not. Well, I'll show you something later. So how does column store work? This is a bit of, okay, fake. I picked German cars by accident. This is not planned. Let's say you have a table and it has make, model, and color, and then a bunch of cars with models and colors. So we have 2 Audis, 2 BMWs, and most of them are black, and there's a red one. And we want to turn this thing into a column store scenario. Now, first things first, if you do select star from this table where, give me the Audi A4, you'll get 1 row back. And if you say, I want to make it a model, you're also getting the color. Because it's on the same row. It will be loaded into your CPU memory and whatnot. There's no way you can not load it. SQL Server won't show you, and it might do a different index choice if you don't specify it, but it's still, this row is connected. It's stored that way into the pages in SQL Server, etc. So it's not disconnected. So the first thing that column store does is it makes separate columns. So they're stored separately. That's why they're called column store. They're still in the same blocks, but they're stored separately. So if you only want to make, then it doesn't have to read the model and the color. It leaves those things alone. It does a few other things, and these are important. First of all, it makes blocks or segments, and they're 1024 times 1024. Max, right? Maximum. This is what it tries. You're compressing stuff. There's compression, so you need memory. If you don't have enough memory, it can't fill it up to the max, and it will stop maybe halfway and fill it up only with 500,000 rows and move on to the next one. So you get smaller segments. You get more than you need, and it might be so much overhead that your system becomes slower. So first thing that you need to do when you make column store is make sure you have enough memory. So in Azure Data Warehouse, this means you may need a larger resource class, which gives you more memory, which compresses better because it can use all the memory. Second thing that it does, for instance, in the make column, we had Audi and BMW, and it doesn't repeat Audi, BMW, BMW anymore. It says, you know what, Audi equals 1, BMW equals 2, and I'm just going to say I have 1, 1, 2, 2. This is a nice compression. And it also means I have to make a dictionary inside my segment. And this dictionary has a maximum size. It's 16 megabytes right now. So if you have too many options, then it will run out of memory in that dictionary, and it will stop compressing and move on to the next one. So this is the second reason that your 1024 times 1024 might not be it might not be perfect, because it runs out of dictionary. Dictionary. You have dictionary pressure. Second thing that it does is and this is where it gets interesting. It starts repeating. It stops repeating the section. So where in the make column you had 1, 1, 2, 2, it stops doing that. It will just say, I had option number 1 twice, and then I have option number 2 twice. And that makes it shorter so you can fit more in, right? This compresses nicely, and it does other things like to choose the right type. Like if you only have 6 options, it's not gonna use an int. It's not needed. That kind of stuff. But this is an interesting thing happens here. This disconnects the rows from each other, because the model cannot compress it that way, because you had an A4, A6, M5, and an X5, so it has to do 1, 2, 3, 4. So this disconnects the connection. So every time you're asking for the Audi A6 or something, it will have to break open the column, figure out which row it is, and then do the same on the model and get to the same row. It has to do some calculations there because it's not on the same place anymore. It lost its connection basically, and the same goes for color. This makes it really powerful, compresses really well, and the whole speed of this thing is based on skipping stuff. So if it's smaller, it needs to read less, and if you didn't specify the color, it will not read it. It will not go through it and figure out which row belongs to what. Disadvantage there, if you do a select star, it's even worse than normal, because you know this, right? As a SQL Server, if you do a select star, you lose the opportunity for SQL Server to pick certain indexes. It will probably then usually go to the clustered index and not use your non-clustered indexes. Column store does not have that problem because there's no binary tree. It doesn't have that. It means something, but I'll get to that. But it has to do extra work if you do a select star. It's even worse than with columns with a clustered index. So select star slows it down even more than you're normally already used to. So if you can prevent doing a select star, it doesn't have to read it, also doesn't have to process it, and will make the thing faster. That's what makes column store so powerful. Now, one more thing, it also does a min and a max per segment. It says, okay, in this block of data, I have between Audi and BMW. If you're looking for Porsche, not in here. You don't have to read it. So the SQL Server comes by, grabs the block, looks at the bottom, goes, there's no Porsches in here. Skip. I'm not going to do any processing any further. That makes it very, very powerful. And then on top of that, you can partition it. This is outside of this calculation stuff. You can partition it where it already knows, okay, 2005 data, not touching that. There is no Porsche in this block, so I'm not touching that, etc., etc. So the elimination is the most important. It doesn't have a B tree though. There's no index. You're basically getting a table scan. Every time you look something up in a column store, it's a table scan. It's a really fancy one. It's a really fast one. If you made sure you don't have any dictionary pressure and no memory pressure, and you didn't do select star and whatnot. If you do a select star from everything, it might be slower. It still is less I/O because it's compressed, but it's a table scan. You're still getting a table scan. Now, why is this important? For us, it was important. Let's go back. Where are we? Oh, one back. Here. If I go and check, there's a view that you can run. The view is documented. I'll grab after the session. I'll grab the link and post it in the comments. But there's a view documented by Microsoft that you can run inside your data warehouse, and then you can use it to look at what your table looks like. And I have the post history here, and you can see it has 180 segments or buckets, and most of them have no trim. That means perfect. They would have the 1024 times 1024 data. And then here is the bulk load. This means after the loading of 60, so it's probably, yeah, it did exactly 60. So it had 2 times 60, so 120 segments per it did 60, then it was done. It had 1024 times 1024. It did it again. It had 1024 times 1024 again. And then it had some data remaining. That wasn't enough. and it did it in all the 60 parts, and it just stopped when it was done. And that's what the bulk load means. You can actually probably calculate that. Calculator. I have 1024 times 1024 is 104576. So that's correct. And then I had that twice. I have 120 of them. So if I do 120, those are my rows that were perfect. But the total number of rows is 133. So yeah, we can calculate that. So if I do a minus, and it will get into the minus, doesn't matter. 133,805,704. There's 7.9 million left, and they're divided over the 60 buckets. So if I do divide it by 60 buckets, because this was round robin, we'd have approximately 132,000 items in one of these buckets in the beginning, because not in the no trim, but in the bulk load. And as you can see, that's fairly correct, right? So it just had 60 times 132,000 left, and it couldn't make perfect. So it said bulk load. You didn't give me enough. Your bulk load was limited because you specified, or I just didn't have any more. Now, I'm already talking for an hour. I'll get to the part where one other thing we didn't do with column store. We stopped using column store for one scenario. We had one query, and the 1,000 users that we have would run that one query many times a day. It was actually sort of kind of an OLTP query. It had to, the on-prem system had perfect non-clustered indexes for it, and had to be run in like a second, half a second. So the first time we did this on this butt, it had 60 billion or 70 billion rows. So the first time we did this on column store, mind you, there's no tree, no B tree, so no index. So it would just be a scan through everything. And that scan was fast. Tens of billions of rows, and we still got an answer in 12, 13, 14 seconds. We thought, okay. But the users said, no, it has to be faster. So we thought, okay, let's create a non-clustered index. And then because you're doing a select star, couldn't be helped. It will just do a non-clustered index. We'll do a range scan there, take the 10, 20, 30 rows, not many, that would come out of the non-clustered index scan and do 10, 20, 30 lookups in the column store and doesn't have to do a scan. That's how we thought it would work. Unfortunately, actually that is how it works. It does a lookup of the row in the column store index. Unfortunately, doesn't scale, especially if your data is in many segments. So it has to crack open the metadata of all these segments just to get the one row out. And then also all the columns. So it has to do all these calculations. It just didn't scale, and it dropped off a cliff for us. We got 30, 40, 50 seconds of response time. So the scan of everything worked even faster than the non-clustered index with the 20, 30 lookups. It just, 1 was fine, 2 was fine, 5 was already noticeably slower, and 20, 30, take a minute. We were not happy with that. So we had to take that one table, drop the column store, create an just as on-prem, exactly same scenario, clustered index with a few non-clustered indexes that would help us there. And it was perfect. Another thing is that we had 2 scenarios with a different key. So we also couldn't distribute it in a certain way and see if we could fake it a bit faster scanning, because we tried to move all the data so it would be in one bucket. Just hash it on that, and then it would be in one bucket. So it would be a table scan of column store, but on a small table, on a 1/60th of it. But no, that didn't work because we had 2 scenarios with different keys. You can only store it in one way, and it was still slower. So that was the one scenario where we chose for not having column store, where we were depending on lookups in the column store that came from a range scan in a non-clustered index. That just did not scale well. One last thing, and then I'll stop talking, I swear. This is an example. Column store, as you saw before, because it loses the connection between the rows, that also means that it's not, you can't update it, because then it won't be correct anymore. It has, once it's compressed, it's read-only. Microsoft even calls their column store index updatable column store. That's nice marketing, but what they mean is if you update a column store, the new row goes into a normal table that is not column store, and we also have a bitmap that tells us that that row is not valid anymore. So anytime you read from column store, you're actually joining the three systems and give you the correct answer. But if you do that too much, if you do, for instance, in your in your SSIS, which does maybe an update of a status of the whole table, that would immediately make all the rows not column store anymore, but row store, because it has to make a copy because you changed something that is not changeable. So that's why your old school SSIS might not work. You may want to redo everything. So a thing that you do, you use CTAS a lot, the create table as select. I have seen situations where creating the table again as a copy with 100 million rows was faster than updating 1 million of them. The updates killed it, and just create a complete copy and then drop the old one and rename the new one was faster. This thing has so much power, but you have to use it, or else with the old school scenarios that would be best practices in an on-prem SQL server are not best practices at all in a Synapse. You'd have to break the rules a bit and use the raw power of the thing. I have been talking for more than an hour, I see. Yes.
Yes.
I'm going to stop now. That's me. That's it.
Yeah.
Thank you very much.
Excellent talk, I would say. Yeah, let's try this. Try this functionality in Teams to give you some applause.
Yeah.
Oh, thanks.
Definitely did.
Yeah, this is the problem with Synapse. It's hard to use just demos, and you have to explain a whole lot of the theory behind it to just get the point across. The original slide deck that I did the training for PDW, the old school thing, to Microsoft pre-sales and HP pre-sales, and that slide deck had 1,000 slides. Let's not go there. I still have a copy if you're interested.
Oh man.
Yeah, great stuff. There were quite some discussions in the chat about how much data you can store in which kind of index and how big your tables can get and everything.
So they can be quite big.
Yeah, but since a lot of that was already answered in the chat, I decided not to interrupt you because basically all the answers were already given.
We had one scenario where the tables were not that big, but it was a three-way join with a self join, and two were on the same. Yeah, two were on the same key, so we could hash the two on the same one, but then the third one would always cause data movement, and we just picked the one that had the smallest result set out of the three, and decided to hash on the other two. So the biggest ones would be hashed and would be fine, and then the third one would cause a shuffle. And there was nothing we could do about it. But we found that out by trying.
Yeah. I think that's exactly my experience from looking back at PDW times and APS times. Do you think there's been any major improvement in Synapse that made it easier to use, like more foolproof? Because I think that's what the issue is in some way. You cannot, tell people, well, you can use the system, it's enormously strong, it's in the cloud. All you can do is, just make it faster or slower with the push of a button. And then you have to do a lot of thinking about how does it work. And if I make a mistake, it's never going to be fast.
Then you have to show the 1,000 slides.
People telling something like this is Microsoft sales or marketing or so, but it's, well, if you're handling some, let's say, 50 terabytes of data, it's a hard thing to do. And like André explained, you have to know a bit about your services, right?
It's the old school. There are fans of schema on read and there are fans of schema on write, and this is clearly schema on write. You have to think about it up front, but just replace the word schema with pane and decide where you want it. Right. It's I happen to work right now on a project that has Databricks and Snowflake and Synapse. And they all do it in a different ways. Databricks is actually similar to Synapse because it also, the Parquet format that Databricks likes a lot is basically column store. It's the same thing. And Databricks doesn't have indexes. There's the situation where we decided not to use column store but have indexes wouldn't be possible in Databricks. It just doesn't have indexes. It reads from files. Snowflake, you can't think about how you store it. You just dump it in there and you
Hope for the best.
yeah, no, it's pretty powerful. It's fast. It scales up nicely, but oh my God, it's expensive if you throw data at it. Oh
exactly.
Yeah. Yep. So this is a different kind of problem. If you just want to get started and you just want the thing to work and not think about this because you have to move, Snowflake will work for you. But this is quite a lot more expensive if you get into these scenarios. You just don't have a choice. The only choice you have is pay more. And with this, you can tune it. I have a preference there.
And their sales is better than ours, obviously.
They're old Oracle people, right? And there's almost
and Microsoft too. Microsoft too, yeah.
Oh, Microsoft as well. Huh?
Yeah. We lost some good guys to Snowflake, yeah.
There's almost €1 billion of venture capital invested in that thing.
I know.
So
I know.
It works. It's nice, but
guys, the next version of Synapse is not too far away. I don't know. Maybe April we go into public preview of V3. Let's say moving to another, let's say different architecture. For instance, I always ask everybody, why about this 30 slots? And we will change this and get more Snowflake, like hopefully. Another thing is which is really painful, scaling up and scaling down comes to the cost of being not available. This is really hard for my customers. And this notion of, let's say, virtual or whatever they call it, Snowflake, you know it better than I, André, virtual data warehouses, I think that will be on our roadmap as well. Hopefully we see this in April. I'm not quite sure. Another thing is that we will let's say, be more let's say aligned over all the SQL SKUs. So here we call it a workload management, or let's say workload classes and so things like that. So it will be more aligned over the different flavors of SQL Server. It's another thing, but I'm quite looking into, let's say, for God's sake, let us scale up transparently. And let us have virtual data warehouses. This would be really nice. Yeah.
The competition is clear. It's clear to see that Microsoft is the gloves have come off, and okay, Snowflake and Databricks. Let's do this. And it's going to be interesting to see.
Well, I'm not too sure about Databricks because, let's say, internally for Microsoft, we have a lot of sessions currently about, let's say, using data lake Databricks in a data warehouse style, which is interesting to me. So building in transactions into Databricks and something like that, and so setting up Databricks as a compete to Snowflake, and I'm not really sure if that really works out. Let's see.
So I have a scenario where there is no querying whatsoever on the end result. The only thing that happens when the fact and dimension tables have been created is loaded into Power BI. So their Databricks is perfect because there's no SQL need for SQL. Once we're ready, Parquet files, dump it into Power BI, done. I'm gonna let my Brexit cat in here. Come on. Yes. So sometimes it's a Brexit cat. I have to open the door and then she doesn't come in.
So have you tried SQL serverless for let's say it's kind of a similar approach to let's say Spark?
Did you test serverless pools? I quite like them.
I like them. They can run out of control sometimes where I think, okay, I want to figure out this thing a bit better, and it changes behavior on me sometimes. You can tell it's new. I like where they are going with that. It's also the where they have Spark pools in there, right? Like a Databricks cluster, but without the Databricks layer on top of it. They're making their own layer. Okay, let's see where that goes. I like the plug and play thing. I hope Microsoft doesn't go too far with the no plug and play. We'll just plug it ourselves and you can play with it, but no, you can't do the plugging yourself.
There's a point for not using Databricks, honestly. So it's a bit. So oh, your cat.
You want to say hi? Come on.
Where is it?
This is Princess Leia.
Whoa, impressive.
Yeah.
Is already 13 or 14-year-old already, so old lady.
Old lady, yeah, exactly.
I'll let her out.
Looks at least like a 2000 DWU, I would say.
Yeah, the thing is, Databricks is a cool Azure service, I would say, but there's, let's say, and we are recording this, so I have to be a bit careful. We're talking about, let's say, two different companies that joining for, let's say, one single service, and that's a bit problematic, I would say. And so, the ADF team, which is also building the pipelines for Synapse, decided not to go for Databricks as the compute backend, so to say. It's all a bit. I experience this a bit. Problems being, let's say, sometimes we're kind of a ping pong game between two, let's say, support engineer teams and something like that. So I think it's a good idea to go to Spark open source in Synapse.
Yeah, why would you pay with the Databricks if you don't have to, right? Just use the open source part.
For sure, they do some optimizations. They're clever and so forth, and it's nicely if it works. And I think 90% of the time it works. But especially when it comes to Azure Data Factory, we are seeing a bit of maybe itches there, a bit of problems there, maybe. So please, you have to cut this out of the final video, Marcus.
Yeah, and because it's being recorded, I have to mention that no animals were harmed during the making of the
Definitely not. I've taken good care of her for 14 years already. The cat is fine.
Yeah, André, thank you so much for joining us today.
You're welcome.
As I anticipated, I learned a lot.
Oh, cool.
And I really hope that once we're able to do in-person events again, that you will be able to join us in Berlin for a presentation someday.
Should be easy. There's just one road between Amsterdam and Berlin. Just go east.